Okay, solve the following recurrence relation. T of n is equal to 2 into t of square root of n plus 1 for n greater than 2, and t of n is equal to 1 for the base case. So there are 4 options given. Now how to solve this recurrence relation? This recurrence relation is solved by using a simple trick called variable substitution. With a variable substitution, we convert this into a known recurrence form. Okay, if you have doubt on how to do a variable substitution, you can check the previous videos of mine where I have clearly mentioned how to do a variable substitution and how to solve by using variable substitution. Okay, so what we do here is we will do a variable substitution, that is substitute n by e power x. So when you substitute n by e power x, then this will be t of e power x is 2 into t of e power x by 2 plus 1. So if you consider some s of x as t of e power x, now s of x by 2 is t of e power x by 2. So from that you can say that it can be written as s of x as 2 into s of x by 2 plus 1. So this is a known recurrence form. This can be easily solved by using a repeated substitution. Now if you consider this s of x as 2 into s of x by 2 plus 1, now s of x by 2 can be written as 2 into s of x by 4 plus 1. Now if you substitute, then we will get s of x as 1 plus 2 square into s of x by 4. If you do k times the substitution, then it will become s of x as 1 plus 2 square plus so on up to 2 power k minus 1 plus 2 power k into s of x by 2 power k. If you assume x as 2 power k, then it will be boiled down into a base case. Then it is s of x as 1 plus 2 square plus so on up to 2 power k. It's a GP series. Then you can write it as 2 power k minus 1 by 2 minus 1. That is order of 2 power k. As we know that x is 2 power k, we can say that s of x as theta of x. Now once you know the s of x as theta of x, and we know that s of x is t e power x and e power x is n, if you consider x as log n base e, then we'll get t of n. So s of log n base e is t of n. So from that you can say that t of n as theta of log n. That is the solution.